You are most welcome to our fifth episode in trigonometry for advanced level mathematics. And as it was for episode 4, even our episode 5 will have two parts. And it will be focusing on the factor family. Shall be focusing on the factor family in these next two half episodes. Shall have episode 5a and episode 5b, all focusing on factor family. But the last episode, the last part of episode 5 will be a special treatment of the harmonic form. Shall be seeing it later. My name and context are displayed on the screen, and this contact is also accessible on WhatsApp. Okay. The factor formulae are a set of formulae that help us express the sums and differences of sines and cosines as products of sines and cosines, and vice versa. Now we have four factor formulae, and the first one deals with the addition of sine. Sine plus sine. Sine A plus sine B becomes 2 sine cos. 2, not the order, 2 sine cos. Now we are beginning with adding the two angles A plus B, then dividing by 2. Then we subtract the two angles A minus B, then we divide by 2. Then sine A minus sine B is the same thing, 2 sine cos, but this time you begin with the difference and end with the addition. But in each case, you add the angles, divide by 2, subtract the angles, divide by 2. So for addition, we begin with addition and with subtraction. For subtraction, we begin with subtraction, we end with addition on the right hand side. But it is all sine cos. Now we move to the cosine. Cos A plus cos B, cos A plus cos B, we get 2 cos cos. It is cos cos. But we begin with the addition, divide by 2, and with subtraction, divide by 2. But since they are all cos cos, whatever you begin with or whatever you end with will not be consequential for cos plus cos. So cos A plus cos B is 2 cos A plus B over 2 cos A minus B over 2. Then lastly, we have cos A minus cos B. Cos A minus cos B is sine sine, 2 sine sine. But now you add, divide by 2, subtract the angles, divide by 2. But don't forget there is something here. Majorly for cos minus cos, there is a negative. There is a negative. It's very important for us to recall that one. All the other three are positive, but for cos A minus cos B, we begin with the negative sign. Let's go straight to the activity. It will help us consolidate this, what we have seen. Number 1 says show that sine 70 plus sine 50 degrees is equal to root 3 cos 10 degrees. Now, this is sine plus sine. So we said for sine plus sine, we said we shall bring 2 sine, add the angles, 70 degrees plus 50 degrees, divide by 2, then cos 70 degrees minus minus 50 degrees, we divide by 2. Here we have 2 sine 70 degrees plus 50 degrees is 120 degrees. Divided by 2, we get 60 degrees. 70 minus 50 is 20. Divided by 2, we get 10 degrees. Our common angles, sin 60, so the root of sin 60 is root 3 over 2. That was in our second episode. Times root 3 over 2. Then the cos of 10 degrees. The 2 goes with the 2, and we end up with root 3, the cos of 10 degrees. This one is our right hand side, as it is required of us. Question number 2, show that cos A minus cos 13A is equal to 2 sin 7A sin 6A. Cos A minus cos 13A is equal to 2 sin 7A sin 6A. Now, again, we shall begin with our left hand side. Remember, we are expecting to subtract, divide by 2, add, divide by 2. So, my advice here is to always begin with the bigger angle. Here is 1A, that is 13A. So, I better rearrange so that I can begin with it. I can begin with the bigger one so that I don't get the hassle of dealing with negative angles. Minus cos A. But once I do that one, note that I have multiplied by a negative. So I get negative cos 13A, which is negative in the question. Then negative times the negative gives me a positive cos A. Good. So inside the bracket for subtracting cosine, we shall bring in our formula. It is negative 2 sine. You add the angles, 13A plus A out of 2, then sine again, 13A minus A divided by 2. Negative negative brings us a positive. Now the positive that comes here, you get positive 2. 13 plus 1 is 14, divided by 2 is 7. So sine 7A. 13 minus 1 is 12, divided by 2 is 6. Then sine of 6A, which is our right hand side as required. We now move to question 3. Show that 2 sin 3 theta cos theta is sin 4 theta plus sin 2 theta. Now this time we are moving from the product and coming to the sum. At the beginning we said that the factor formula can help us to do it in both directions. Now let us see how this one will come out. Again, we shall deal with the left hand side. Left hand side. Now we have 3 theta, we have theta. So it is sine cos. Now the bigger angle 3 theta comes from addition. The smaller angle theta comes from subtraction. So what if we let this 2 sine 3 theta cos theta be equal to, because it is cos sine cos, so it must be sine A plus sine B. We don't know these two angles, which we can get. If we prove that A is 4 theta and B is 2 theta, then we would have shown what we need. So this being our 3 theta, it means here I would have this A and B. This is A plus B over 2, then cos A minus B over 2, which means by comparison, A plus B over 2, this one is 3 theta, which means A plus B is equal to 6 theta. Let's call this equation 1. Also, A minus B over 2 is a theta, which means A minus B is 2 theta. Call this equation 2. So we are going to solve these two equations for A and B. So equation 1 plus equation 2, we shall have 2A is equal to 8 theta, which means A is 4 theta. Put A in equation 2. A will be our 4 theta minus B is 2 theta. Then we rearrange and we discover that B is 4 theta minus 2 theta, which is 2 theta. So therefore, what we have there as 2 sine 3 theta cos theta is the same as sine A. We are now putting them back here. Sine A, now A is 4 theta, sine 4 theta plus sine B, and our B is 2 theta as required. We proceed to question number 4. Please, any part of this video that you haven't understood, you can contact the number given at the beginning of this video and also saved in the name of this video on YouTube. Show that sine theta plus sine phi over cos theta plus cos phi is tan theta plus phi over 2. We are still beginning with our left hand side. Now, sine theta plus sine phi, we are adding sine. We said for adding sine it is 2 sine cos, but we begin with addition. Divide by 2, then cos theta minus phi, also divide by 2. Out of now cos plus cos, we said is 2 cos cos. 2 cos theta plus phi over 2, again cos theta minus 5 over 2. The 2 will go with the 2. This one will go with that one. And sine out of cos is tan. Tan theta plus 5 all over 2. This is our right hand side as is required of us. We now go to question number 5. Question number 5. Now for question 5, these are 3 and we don't have a rule that works on 3. So we are going to pair them. First, we get 2, which we can easily add. Then we end the others. Now, when you look at our right hand side, we have tan 3 beta. Now, tan 3 beta obviously comes from sin 3 beta over cos 3 beta, which means whatever we shall do in our mind, we should end with a sin 3 beta on top and a cos 3 beta down. And since we have them already on our left hand side, it is a good hint that we can begin by leaving them intact. Good. So we shall first leave them. We shall pair these two. And again, as I've said, when you are expecting to use subtraction somewhere, it is preferable for us to begin with a bigger angle. So we reorganize on the left hand side and we have sine 5 beta plus sine beta, then plus sine 3 beta. I have made no change other than rearranging. Now down we shall have cos 5 beta plus cos beta, then plus cos of 3 beta. Now applying our factor formula for sine in the first bracket here on the numerator, we shall get 2 sine cos. 2 sine cos. 5 beta plus beta is 6 beta. Divided by 2, we get 3 beta cos. 5 beta minus beta is 4 beta. Divided by 2, you get 2 beta. Then plus sine of 3 beta over cos plus cos is 2 cos cos. So 2 cos 5 beta plus beta 6 beta divided by 2 is 3 beta. 5 beta minus beta is 4 divided by 2 is 2 beta. So cos 2 beta. Then plus cos of 3 beta. When you look at our numerator, sin 3 beta is common. Sin 3 beta is common. So we remove it or factorize it. And we remain with 2 cos 2 beta plus 1. Then denominator, cos 3 beta is common. We remain with the 2 cos 2 beta plus 1. Now these brackets are the same, so they will cancel out. We remain with the sin 3 beta over cos 3 beta. It gives us the tan of 3 beta, which is our right hand side as required. We now move on to question number 6. Question number 6. Question number 6 says, show that tan over half a minus b plus tan over half a plus b is 2 sin a over cos a plus cos b. Still, we shall begin with our left hand side because it is show, not a proof. So what we know is that tan a half a minus b is the same as saying sin a minus b over 2 over cos a minus b over 2, because tan is sine over cos, the same n plus, the same thing will apply here, sin a plus b over 2 over cos a plus b over 2 shall have the LCM, or you can simply cross multiply cos a plus b over 2 cos a minus b over 2. That is in our now denominator. Now this one times this, you'll get sin a minus b over 2 cos a plus b over 2 plus this will be sin a plus b over 2 times cos of a minus b over 2. Now, at this stage, we can see something formula. All these three that are in this expression, the two in the numerator and the one in the denominator, they all appear as almost the factor formulae. They are only remaining with the 2, which is missing as a coefficient, and which we can introduce by multiplying through by 2, both numerator and denominator. Based on your rating, this becomes another step. I'm putting the 2 here, just shorten my video. So 2, 2, 2. Now, I have multiplied 2 both in the numerator and in the denominator. So what happens? We realize that the first one, this one alone, 2 sin a minus b over 2 cos a plus b over 2. If you remember, this was sin a minus sin b in the factor formula. It was sin a minus sin b. Then this one, the second one, was sin a plus sin b. And then down, 2 cos cos was cos a plus cos b. Now, sin b will go with sin b, negative plus a positive, then we have 2 sin a. This will be 2 sin a out of cos a plus cos b, out of cos a plus cos B. I think that one is our right hand side. Yes, right hand side as required of us. That is our right hand side. It is equal to our right hand side as required of us. Sure. We are now proceeding to question number 7. Question number 7. Show that cos squared alpha plus beta plus cos squared alpha minus beta is equal to 1 plus cos 2 alpha cos 2 beta. Now, what I'm seeing here, I'm having squares on cosine. They don't have the squares. So what comes to my mind first is to see how to eliminate those squares. We go back to our multiple and submultiple angles because you have seen 2 alpha, here I'm having alpha. So I think the best way forward here is to think along that line. We introduce that idea. We know that you're beginning with our left hand side. From we know that cos 2, I'm now bringing the idea of multiple and submultiple angles. This was the same as 2 cos squared alpha plus beta minus 1. Now, I want this one to be made subject. So this negative 1 will come to the left as a positive 1, then we divide by 2. It means cos squared of alpha plus beta is the same as cos of 2 into alpha plus beta plus this one which has crossed over 2. Similarly, because we shall go through the same procedure, we shall have cos squared alpha minus beta is supposed to be the cos of 2 into alpha minus beta plus 1 out of 2. Now these ones we shall put them on our left hand side. Therefore, my left hand side will now simplify to cos of 2 into alpha plus beta plus 1 over 2. This one has gone in the place of cos squared alpha plus beta. Then plus, now this one will replace this plus cos 2 into alpha minus beta plus 1 over 2. Now, we are seeing a common denominator, so we can basically add the numerators. It will be It will now be the cos. Since it's our last question, we can just proceed downwards. There is no other question below here. Okay. So our LCM is 2. We are adding the numerators. So we shall have cos 2 alpha plus beta plus cos 2 alpha minus beta. We have been able to add the trigonometric ratios together. Then 1 plus 1 is 2. Now, cos plus cos is supposed to be 2 cos cos. 2 cos of 2 alpha plus beta plus 2 alpha minus beta, all of it divided by 2. Then cos again, 2 alpha plus beta, this time minus 2 alpha minus beta over 2 plus our 2. Not forget it. Everything here is out of 2. Let's now open the brackets. 2 cos. 2 alpha plus 2 alpha is 4 alpha. This is 2 alpha, that is 2 alpha. Then we have 2 beta plus negative 2 beta, that is 0. So this one is over 2. So now it has collapsed to that. Then we come here, cos 2 alpha minus 2 alpha will collapse to 0. Then 2 beta minus plus, that is plus 2 beta. So 2 beta plus 2 beta is 4 beta divided by 2. Then plus a 2 over 2. By 2 ones, by 2, 2. By 2 ones, by 2, 2. These 2 divides these coefficients. By 2 ones, by 2, 1, by 2, 1. You get 1, this one here, plus cos 2 alpha cos 2 beta, which is our right hand side as it is required of us. So look out for the second part of this episode or lesson about factor family. Now in the second part, we are going to extend our factor family to look at the harmonic form. and we shall also use that harmonic form to solve some trigonometric equations. So the second part will be a little bit longer. It might even go up to almost an hour. That's why I said split this topic into two. We don't want very long and boring videos. Thank you for following. Don't forget to subscribe to the channel where you have access to this video from. Thank you.